So the last track that we're going to present here for RTA studies by themselves is production normalization. And we're going to start by doing a case study in the Spraberry. And we're looking at 4 plug-and-perf horizontal oil wells here. 1 was from operator A, and 3 were from operator B. The operator B wells, all of them, were better than operator A. And operator A wanted to know why. So we were tasked to use our RTA and rigorously normalize the rock, fluid, completion, and well properties, which are all possible through modeling. The study is going to demonstrate that the differences in the well performance between operators A and B can be entirely explained by different lateral lengths and frac densities. If we were just to take a look at the performance of these wells as we compare them, and we just normalize per lateral foot, per stage, per proppant pumped, we wouldn't have come out with the same conclusions. And that's what a lot of operators do in order to compare wells A to B. In this case, you're going to see that RTA demonstrates that it's going to do a far better job of that. So we'll look at all the production histories as illustrated using a plot of cum versus time. And here we can see the operator A well being the underperformer. And you can see that it was drilled with a 5,000-foot lateral with 250-foot stage spacing. But operator B decided to be more aggressive with their completion and their stimulation design, and they put their stages closer together. So there's more frac density for operator B, but the laterals were roughly the same. So what we did is, after we looked at the performance data for operator A, we characterized the rock, we just changed the stage density in the model. And lo and behold, we got the same performance as those 2 operator B wells, assuming the same configuration. Then we looked at that 8,000-foot lateral, and we decided, okay, well, what if we kept that stage density that we just changed and we made an extended reach lateral to 8,000 feet? Bang, it's like right on top of it. This is real data. So in this case, it's absolutely apples to apples across the board. Operator A and operator B can achieve the same well performance results if they do the same well completion design. Now in this particular project, there were other slight little changes to initial water saturation, slight variations in petrophysics, but the RTA could account for all of that as well. These weren't the dominant variables. The completion detail was the dominant variable, which is why we're presenting it, but it did normalize other things as well.